Okay, let's start putting together some of these various theorems. Now, to put together these theorems, we have this picture here. We're given a couple things. We're given that DE equals EG. Got it. And DE equals EG in the given. DF equals FG. And we put that in the given. Now, we also have EF bisects DEG. So EF bisects DEG. Now, of course, we remember that bisects means to cut in half. So, folks, I cannot stress strongly enough how many times people mess this up. The segment is cutting something in half. It's bisecting. But what it's bisecting is not the segments, it's bisecting the angle. So this is shooting right through this big angle, and by shooting through the angle, it bisects it, cutting it into two equal parts. That means this part is equal to this part. So by saying that something bisects, it cuts it into two equal parts. But now I have to tell which angles those are. This is where kids script. They go, oh, it makes two angles. Which two angles? Tell me the two angles. The angles that it makes in this case is this angle, which would be DEF. So angle DEF is congruent because it's the same size. Well, what would go with DEF? Well, that would be GEF. And the thing is, if I'm going to use a fancy word like bisects, what's my reason going to be? Well, definition of angle bisector, because I used angles and it's an angle bisector, even though it's a segment bisecting the angle. Now, you'll notice I haven't used one of my givens yet because my preference, it's a personal preference, you don't have to do it this way, but that is as you use the givens, tell what the givens mean. So if I say something bisects something else, the next statement I ought to have should be that two things are equal to each other. So now if I'm going to say EF bisects angle DFG, well, that's given. That says angle EF bisects DFG. I make two congruent angles. Now, folks, this is congruent to this, but that does not mean it's congruent to the ones above it. The best I can say is that angle DFE is congruent to angle GFE. GFE, DFE. Okay, and that is again because since I used a math word like bisects, by definition of bisects. Now, remember what we're trying to prove. We're trying to prove this triangle is congruent to this triangle. But the only way we know how to prove things congruent is by proving all of the various parts congruent. Well, I'm pretty good. I got this angle and this angle, this angle, this angle, this side, this side, this side, this side. So I have two sets of angles and I have two sets of sides. So I got a set of sides, a set of sides, a set of angles, a set of angles. Well, I need some other stuff. Well, wait a minute. I can say that angle D is congruent to angle G because in any two triangles, if two pairs of angles are congruent to each other, automatically the third angle has to be congruent, third angle theorem. So now I can say angle D is congruent to angle G. So I now have three sets of angles, and to get all parts the same, I'd have to have three sets of angles and three sets of sides. The last side is sitting right in front of us, because here's the thing. EF is in this triangle right over here. EF is also in this triangle right over here. But EF is congruent to EF. It is congruent to itself. And remember, what do we call something when it is congruent to itself? Reflexive. Now, I have three sets of angles, three sets of sides. With three sets of angles and three sets of sides, I can finally prove the two triangles congruent. So I can say that triangle DEF is congruent to triangle GEF because all parts congruent. All parts are congruent. There we go. So that is a theorem. It's not challenging because all you have to do is put the givens down. Once you have the givens, you talk about bisects. Once you talk about bisects, that means some angles are congruent. Once some angles are congruent, you say, oh, reflexive side. Now I have three angles, three sides. That's six pieces. That's the whole triangle. It works out nicely. So with that, take a look at your own theorems.